Hi, my name is Karen, and I did my project on solar energy. To do my project on solar energy, I used the data that was given in class, which told us how much solar energy is produced um, yearly, and we also looked up other data as well to figure out how much total energy is being consumed by a country yearly as well. We combined it to figure out how to maximize the use of solar energy and minimize the use of other energies, such as electrical and chemical. There are a lot more energies out there that are being used in everyday life, but if we were to replace it, if there's a way to replace it with solar energy, it'll definitely reduce the cost and the pollution. Um, it's easy. You can make your own solar energy if you want to. You just need photovoltaic panels. And my code, the purpose of my code is to compare solar energy and total energy that is being used. And then figure out what's the other energies that are being used and how much solar energy needs to be produced in order to make up for that difference between total energies and solar energy. Once that number is calculated, we used a loop to figure out how many extra plants that will be needed to be placed than we already have in a country. We figured that out based on an average of how much a solar energy does produce. So I will be running the code for 3 different countries, and before I do that, I do want to describe my code first. What I did, basically, I placed a menu for all the countries where the user can choose a country, and a bar graph will pop up comparing solar energy and total energies. After that, it'll tell you a loop. I placed a loop which will tell you the difference in those energies as well as how many solar plants are needed to make up that difference. So it'll tell you how many more plants need to be placed in that country to cover up for the difference in total energy production and solar energy. And to run my code, I'll run it for Belgium. Belgium is there's a huge difference between total energy, which is this, and solar energy. There's a lot to be covered, and on the bottom you can see the difference is huge, and the plants are based on an average of how much a solar plant can produce, which is this number right here in this units. And for this specific country, which is Belgium, only 3 more plants will be needed, as well as what we already have in Belgium right now. Let's now run it for United States. United States, it's not as big of a difference. This is a little smaller than Belgium, but it's still a huge difference between solar energy and total energy. And damn, never mind, I was wrong. The difference is huge, and it needs 92 plants to be placed in the United States as well as what's already there to make up that difference. And let's now run it for our neighboring country, Canada. Canada, the difference is huge still, and it needs 11 solar plants to cover up the difference between total energy and solar energy. And to talk about future uses with my code, the loop definitely will definitely help with future uses because it figures out how many extra plants that are needed, and if the number for a country, say for a country, the total energy consumption increases in the future and there's not as much solar energy being used in that total energy consumption, this loop you just need to enter that number, and this loop can figure out how many more plants that are needed more to be placed in that country to cover up the difference.